All right, so I'm sort of afraid to say this, but for the first time ever, and it probably won't be true, because I'm going to say it and then it probably won't be true, and I probably have to reset this camera, we might not use graph paper today. Right? Like, gasp! Because so much of our classwork is on this worksheet. So guys, you need 324 out, because we're going to use all of this stuff in class. So we may not actually have much writing on graph paper, but you need 323 out because we're going to check it. We're going to start today's class by reviewing problem 55 right here. Go ahead. So, here's plan book review if you need. Hey, so this pencil sharpener, you guys just have to be gentle with it. You guys are being like aggressive and it doesn't work well. Unless you all already broke it. Unless somebody broke it. I cannot believe it.
Is it already broken?
Brand new.
Oh no.
I just got this. You broke it in 3 days. You were the one up here.
Yeah, I did
Yeah,
that
yeah.
hard.
Guys, apparently something's wrong with my pencil sharpener, so we'll see. There's a mechanical pencil here. I don't know whose it was. But anyone else need a pencil and doesn't have one? Guys, we gotta bring school supplies. Like, this happens. Like, you gotta have some supplies of your own. There are handheld sharpeners down with the colored pencils. So if anyone else needs to sharpen their pencils, there are handheld sharpeners down there. I gave away my copy of 323 to somebody, so I'm gonna just pull up our answers like this. But please ask if we have any questions about these things. What's up? 61. Yeah, sure, I'd love to when we get to the back. So let's all check 59 first since it's on the front. Then we'll go look at the back. It's really determining who's going to win. But I told Mr. Hall I would start saying the same things he says, especially because he noticed my posters and then he gave me a hard time. He's like, that's exactly what I say. Over here. When we're adding and subtracting, if the signs are different, what we're really going to do is a subtraction. So here's what that sign means. 6 and 18 have different signs. So what we really end up doing is saying 18 minus 6, which is 12, and we keep the sign of the stronger number. That's the same way I teach. Mr. Hall just likes to say I teach differently. But, I mean, we do. I'm just kind of being like a stick in the mud. So then here, different signs, who's stronger or who's going to win, the negative again. So that's how we get negative 12.5. Same signs, we keep the sign of negative and put the numbers together. And in D, before you try to compare the positive to the negative, I would put the positive with the positive first. That's just my technique that I think is best. So I think it comes out to be 22.9. I think because we carry 21. No, 20. Ooh, 21.9. I think actually. I think I carried too much. And then negative 12.2. Who's going to win? The positive. And that's how we get our answer of, 9.7. All right, flipping to the back. Any questions on 59 before we flip to the back? All right, please check that multiplication in 60. I think I see everyone looking at worksheets, but guys, if you lose something, just go tell that teacher. I'm out of extras of this right now, but I could print it for you. So I'm going to show mine again. if we do -3 6 times, right? Like we talked about yesterday, we're using multiplication to say how many times we do something. -3 6 times will really give us -18. If we did -6 3 times, remember my advice yesterday. Put parentheses around this and it looks nicer. And then you have a number in parentheses up against the number in parentheses, which we know multiplies. -18, just like in A. Now the opposite of 8 times -3, or what did we say yesterday about a negative times a negative? It's gonna be a positive. So that's how we get 24. If I do anything 0 times, oh, what's 0? I ordered 8 pizzas 0 times, or what? Well, that's a -8. But if I do anything 0 times, now if I have a debt of $20, and I want to split it up into 5 payments, how much will each payment be? -4. -36 divided by -9. A little hard to think about negatives divided by negatives because it's sort of like going back in time. But if you need to reference the poster right there, 2 negatives, same sign, becomes a positive when we're doing that division. So it is +4. Questions on 60? All right, 61 I was specifically asked to do. This one's tougher because it's partial numbers, and today we're going to get into decimals. So guys, here, I would break this work apart. Put your eyes up on the board, because you might not have done it this way, but now you might be like, oh, well, that could have been easier. -2 1/3, I can think of as -2 and a -1/3, right? Because a -2 and a -1/3, that would make -2 1/3. +7 and 6, I'll deal with that later. 4 times -2. If I take away 2 4 times, I really take away 8. But then I also, this is called distribution, which we're going to do a lot more this year. I also have to do the 4 times the -1/3, which gets me -4/3. Questions on how I got these two numbers? I still need to bring down my 7 and a 6. Questions? I broke up that multiplication. Now, what we actually get when we put these numbers back together from this multiplication is -9 and a third. Sorry, I don't know why I wrote that 4. Because 4/3 is 1 and a third. This turns into 9. Questions on that? I still have that +7 and a 6, though. Lucas? Yeah, and that's what I'm going to do now, so I like that idea. So Lucas said, if I want to turn my denominator into a 6, I need to just multiply the top by 2 and multiply the bottom by 2. Guys, sometimes we can break the numbers apart and sometimes we can't. Here we can because both the number is bigger than the number and the fraction is bigger than the fraction. If that's not true, we probably have to go improper to deal with this. But I can do 9 minus 7. I can do 2 6 minus 1 6. Because remember, over here we say if the signs are different, we're really subtracting. Right? So I say my negative's going to win. But by how much? By 2 and a 6. Questions on that? Now, if you come to me and say, how do I type this in a calculator? I'm going to say you don't. Because you need to be able to work with fractions. In B, this is actually multiplication, right? We said it looks a little weird. I would write it with some more parentheses. But if we do that multiplication, -2 times 3, Negative 6, we get negative 14. To make sure you can check your work here, what's negative 5 times negative 3? 15. Positive 15. So guys, check your work. It's not just about the final answer. Our final answer is going to come from 19 fighting with the negative 7, or trying to add with the negative 7, so the positive is going to win by 12. In D, our final one here, you could actually use a calculator for this, or, break up the multiplication in your head. What's negative 4 times 2? Well, that's negative 8. 0.25 times 2? 0.5. Ooh, but wait. Now we have negative times negative. What's negative times negative? Positive. I don't know why I put this in parentheses, but I did. What's a negative number plus its opposite? 0. Right? Any positive and negative numbers that are the same is 0. So that's a 0, not a 6. And I am not going to show the work on 62. Because at this point, you should know what you're doing, or if you need help, you should come get help from me. But 62A, either 13/12ths or 1 1/12, that common denominator of 12. B, 11/60ths, because the first common denominator between 12 and 5 is actually 60. Yeah, the first common denominator is actually 60, so I'll zoom in a tad bit more. Ooh, a little far. And C, 6/24ths or 1/4, but the 24 denominator, you should have work showing a 24 on bottom, because we multiply, sorry, not common denominator, but the denominator of 24, because we multiply straight across. So guys, if you're still struggling on fraction multiplication, it might be helpful to draw arrows, because 3 multiplies by 2 and gets 6. 8 multiplies by 3 and gets 24. And then we can reduce. Same thing with D. If I draw my arrows across and say 4 multiplies 7, 5 multiplies 8, 7, 14, 21, 28. And I had a couple people come ask me about 63 at extensions. I'm thinking of a number. Guys, if we don't know a number, what do we use? An X, or any variable. You could use the hashtag if you want, because that actually stands for a number. We normally use X. If you divide my number by 3, so that would be X divided by 3, right? And add negative 3, interesting, you will get 4. How do I undo adding negative 3? Yeah, if we take away this negative 3, minus a negative 3 is really adding. So what they're saying is their mystery number divided by 3 is what? What is 4 plus 3? So their mystery number when divided by 3 gets 7. What number when we divide it by 3 gets 7? Lucas? 21. Now we test it because these problems are kind of tricky. So let's test it. I'm thinking of a number 21. If you divide my number by 3, okay, then we would have 7 and add negative 3 and add negative 3. We get 4. That is right. We know we're good. If you have any other questions, you should come to AO or Extensions or Math Lunch. You've got lots of options to get help. Go ahead and put that away if you want, but we need 3, 2, 4 out. If you did not turn in 3, 2, 1 and 3, 2, 2 yet, you should do that now so you don't forget, and then it gets to tonight and I grade, and it goes in as missing. Announcements. Still, homework help videos. If people ask questions, if you can't ask questions during AOR extensions, maybe you could ask questions during, like, email, right? I forget if I brought this up yesterday, but you can always email, right? Like, even at midnight, you probably shouldn't be awake, but I don't care. I'm not checking my email. I'll see it the next day. Whenever you want, you can email me for help. And math lunch is a thing. A couple more of you are going to get that invitation to come because I believe you are behind. And if you can prove to me that you're not behind, then you're okay. You do not have to keep coming. We should have these answers written down. I just wanted to review it and make sure that we did. So yesterday, right at the end of class, so guys, this is still 323. Sorry, I know I just said put it away if you want. But right at the end of class, we answered these questions, so I wanted to make sure that people had it written down. When the signs are different, it stays negative, and we get negative 12 there. If you already have this written down, that's totally fine. I'm just doing a quick review. When you have two negatives, the opposite of a negative is actually positive, so that would become positive. I'm going to do the two below it, then I'll bump over to the right. One positive, one negative is negative. There's nothing to cancel out the negative. But the opposite of a negative, or yesterday we said we could put parentheses around this to see it a little bit easier. It's positive 14. So here, negative 4 times 3, what are we going to get? Negative 4 times 3? Negative 12. And negative 2 times 7? Negative 14. All right, so now we should be looking at this. Hundredths grids. It says examples from class because they are examples from class. Any questions? Anybody having any issues? You should have this worksheet attached to 323. If you don't, I'm confused. All right, so I want you to read this problem and start chatting with your classmates or your teammates about what we're doing here. So Howard went to the mall, check it out together, start trying to figure it out. We should only be using one of those hundredths grids at first. I have papers to pass back, but I'm telling you guys to work on your own. So you don't have to do these right now. They're not your homework. Like 331 is homework Friday. So just stick these in your binder and just keep track of them. You're welcome. So the first thing you want to do is if that first hundredths grid represents $1, can you shade in 40 cents, like kind of nicely? Can we shade in 40 cents of the dollar? Now I'll tell you, let's go ahead and just do it vertically. Let's go ahead and just do it vertically. So on your paper, and I'm actually probably going to use highlighter to do this, if the laces cost 40 cents, and guys, if you've got a highlighter, this would be really convenient. How many of these columns should I... Thank you very much. We'll need 4 of them. So 1, 2, 3, 4. I'm going to shade all of these. Go ahead and shade 4 columns on your paper. Trying to make sure I give you guys a second to be artsy. Beautiful shading, right? Then we'll make some happy trees. Anyone know who I'm talking about with happy trees? Bob Ross. But then, gotta love a good sale. There's a sale. All sporting goods are 1/10 off. Now wait a minute, 1/10, right off to the side, 1/10. How? How do we, what's the fraction to get us there?
1/10 would be also 10/100.
Yeah, 1/10 is also equal to 10/100ths. So the other thing they could put on their sign is 10% off. Which, guys, I want you to start thinking about on. Here's what I mean. Give me your eyes up here. If you take 10% off of something, what percent is still on? 90, right? Because let's show this 10% off. So down at the bottom, this single row, right? That would be 1/10 if I was just looking at the 10 rows. Or if I count boxes, it's 10 out of the 100. So down here, go ahead and shade one row across. And that is off. So 90% is on. If you want to make a little note that 90% is on. So, how many cents ended up taken off of the price of the laces? 4, right? These came off the price. Since it was less than a whole dollar, the rest of the discount didn't really matter because that was discount on money we weren't going to pay anyways. So what am I left to pay? 36 cents. Yeah, for a pair of laces. Now, this book is a few years old. So we would pay, we normally work in dollars, so 0.36, because there were 36 hundredths left. Now, here's the weird thing about these boxes, and I'm going to bump over to the right one so we can talk about this. This distance across the top is 1. And this distance down the side is actually 1. Together, the box, if we have the whole thing, is what percent? If you have a whole thing, what percent do you have? 100. So these boxes are what we're going to use to represent 100% of something. Like 100% of the price. So if there was no discount, 100% of the price, Howard would have paid 40 cents, but there was a discount. So let's move on to the next one and see if this can help us there. So Howard found some new running shoes advertised to weigh only 70% as much as his old running shoes. I'm trying to think colors. What things layer on top of each other. Yeah, I don't have a green highlighter up here right now. His old shoes weighed 8 kilograms. Ooh, wait, not 8 kilograms. 0.8 kilograms. Thank you, careful readers. So 0.8, let's shade 0.8 up here, or 8 of the tenths, right? Every column is a tenth. So really, how many columns am I not going to shade? 2 of them. So go ahead and shade everything but 2 columns. And if you don't have colors or highlighters, just do your first shading kind of lighter. Then you can do your second shading kind of darker. Go in the other direction. There we go, my 0.7 kilograms. Or sorry, 0.8. But then the new shoes are advertised to weigh what percent? 70% as much. So guys, that's not off, that's on. This 70% as much, that's on. They weigh 70% of the old shoes. So that's actually the amount that's on. Let's go ahead and kind of like box that out. So if we could count from the top or the bottom, doesn't really matter. Since we did on from the top up here, let's go ahead and keep on from the bottom, or from the top. If it's 70% on, what percent would be off? 30%. So this percent will be on my 70%. Whereas this 30% is off. So what got kept on is the new weight of the shoes, which is how many? Let's count up these boxes. How many hundredths do we have? Well, it's still 8 by 7. What's 8 times 7? 56. So the new shoes would be 0.56 kilograms because they are 56 hundredths. Questions? Here's the problem. Can I go over 100% with this grid? No, I only have 100 boxes, right? So I would have to like make something extra to go over 100%, and that's why I'm going to show you a different technique. So I forget if there's a story for this problem. So let me double check 66 real quick. No, so I'm going to tell you a story for this problem. So if you can believe it, I like the metric system better than I like measuring in feet and inches. And I think most math teachers will probably tell you they like the metric system better. So I'm planting a new flower garden for my yard, and I decided to plan it out in meters. Meters are often measured with decimals. This is why the metric system's better. It doesn't use fractions really. So if my garden is going to be 2.3 meters wide, you can't see what I'm pointing at. You guys got to tell me if you can't see what I'm pointing at. So if my garden is going to be 2.3 meters wide and 1.4 meters wide, but because I'm a math teacher, I'm going to split this garden up and have some different stuff growing in it. So I'm going to split this garden into 4 pieces. My one big section, I want to be the 2 meters by the 1 meter, but then all the leftover pieces, I need to figure out how much area they take up. So remember, area is always length times width. Or length times height, or width times height, or whatever 2 dimensions you want to call it. So like inside this box, the big one, how am I going to find the area inside the big part of my garden? 2 times 1, which equals 2. I want you with your teammates figure out what multiplications go in the other boxes and verify it with a calculator. If you can't fit it in the box, just do it off to the side, but verify your answer with a calculator, especially for my little corner of my garden. What multiplication do we use for each of those? Verify with a calculator. Oh, this? Dude, you totally could have moved this desk. It's here for math counts. Fine, you guys want to move this? Hang on. Hang on. Oh my God.
There you go! He just zipped across the room.
I was probably sitting alone and then a brother.
Dude, you look sad. You had no team to work with. No man should be an island.
Yeah,
So we're talking about solving the problem, not just waiting.
staying alone calmly than a locust.
So the dangerous thing is this. I was like, 0.4 is a little tricky. 0. What?
Yeah.
What's 3 times 4?
Yeah, so I was like,
So is it 0.12 or is it 1.2? No. Let's talk about the trapdoor, because I love trapdoors. I mean, I love finding trapdoors, right? And sidestepping them. 0.3! I haven't used random cards all day. Hey Zeus! How do I say 0.3 the right way? We'd say 3/10, right? John, don't answer for him. Give him a second to think. Not here. Vincent, how do I say 0.4 the right way? 4/10. So guys, you don't need a calculator. I told you to use one to double check your answer. What is 3 times 4? But be careful, what is 10 times 10? 100. So this area is 12 hundredths, which is 0.12. The temptation people have is they do 3 times 4 and they get 12 and they put down 1.2. No. If there's 1 decimal place here and 1 decimal place here, there needs to be 2 decimal places in our answer. So that would be 0.12. But remember, guys, that's meters squared. It feels small, but because it's meters squared, it's not very small. What about, let's keep using cards. John, what about 0.3 times 1? Yeah, nothing happens when we do times 1. Marina, what about 0.4 times 2? 0.8. So, to total up the entire garden, just grab all the pieces. 2 plus 0.8 plus 0.3 plus 0.12. Careful. What's 0.8 plus 0.3? 1.1. Sorry, I should have put a 0 in front of that. 1.1 plus 0.12. Guys, remember, I can add zeros on the end if I want. What's 10 plus 12? Sorry, I should have brought down my 2 plus. The total should be 3.22. Adding the 1.1 and the 0.12, this is the dangerous part. Questions on that, Lucas?
Is it 3.22 meters squared?
Yeah, so if we were working in meters, when we do meters times meters, like our labels, m times m is m squared. That's where meters squared comes from. We did a meter times a meter, and we got meter squared. Now, I think this should actually be named meters rectangled. I got a couple chuckles. I think this should be named meters rectangled because this is not a square, but the reason we say squared is we could draw out all the little tiny squares that make up this that's what we're talking about, is how many itty bitty squares, and that we actually work in squares. So it's kind of like when you look at a computer screen and you see pixels. Have you ever seen pixels? Your screen is a whole bunch of squares. Every screen is like a whole bunch of itty bitty squares. Now we are actually going to use graph paper because we do have time left. So I am sorry, we actually need to use graph paper. Wow, what a surprise. I mean, you can if you want. If you want to be able to use it, you can keep it out. On your graph paper. I don't know, that's up to you. Write down 2.3 times 1.4. Wait, that's what we just did. Let's practice something different. I don't have time to discuss that. We're doing this one. So, write down 0.3 times 0.16. Yeah, that's my plan. I mean, I was hoping to have them done. Yours are done being graded. I just didn't put P's or M's or anything on them, but I think I'm going to have you guys give your final grade. Like, I gave you all the feedback, checks, and question marks and stuff. 3B, my other Math 7 class, I didn't finish yesterday. So, I want to do it on the same days, because otherwise I get really confused. I already have to keep track of 3 different math classes. I teach Math 7, Math 8, and High School Math 2. My brain is going like this all the time. And sometimes it goes like that, straight to the ground. Sure, can you? Okay. Do you want to come up and give it a shot?
Well, I was just gonna.
You can stay there. It's all right.
So would the 0.3, if we were doing like transforming it into like a fraction, would that be 3/10? And then for the 0.16, it'd be 16 hundredths.
Guys, this is why I've been such a stickler about the right way to say these names. Write this down on your paper. This is way easier than stacking multiplication and having to see how many zeros. And so guys, I almost didn't want to show it because this method always confused the crap out of me. Because where is the decimal going? Where did this zero come? Like, there's all these rules that you got to remember. This is easier. And guys, remember, I'm here to try to make your life easier. John, what do we do now?
Now you multiply the, you can just multiply straight across, can't you? Right?
Yeah. And I like that you just said just. Because it's not that hard. People use the word just when they're, like, comfortable. Oh, you just have to walk down the hall. Right? You just have to multiply across the top and across the bottom. What's 3 times 16? If you don't know it, break it up. 3 times 10, 3 times 6. 38, 48. Guys, this is why once you're doing this, all you have to do is count zeros. 1, 2, 3 zeros. I'm going to put a number with 3 zeros in bottom. 1, 2, 3. 48 thousandths. But now, hey, here's the trick. Or not the trick, the trap. This is not, don't write this. This is not this. Give me your eyes. This is 48 hundredths because it ends in the hundredth spot. Your denominator tells you where your number ends. So when we go to write this out, we have to put an extra 0 here. So our 48 ends in the thousandths spot. Here's my trick I do. I underline the tenths once. I underline the hundredths twice. And I underline the thousandths 3 times. 3 zeros takes us to that third place. So we have to put this 0 in extra. Questions? So guys, I'm here to say fractions are better. Now, if you have a calculator and you're just using calculators, sure. Can you type that in your calculator? Yeah.
Yeah, but it's more fun to do.
But yeah, especially like we start to get comfortable enough with these, it's faster to do this than get a calculator. I think we got a rectangle one. No, not yet. Try these on your own. You can either use the hundredths grid, like 3/10 and 6/10. We could probably shade 3/10 and 6/10 and figure that out. Or make them fractions. I just told you that this is 3/10 and 6/10. So if you make them fractions, I don't know. I think that's easier than having to draw out 100 boxes. Ooh, I heard I'm already done. Flex it over here. Carmen's over here flexing her skills.
Yep, it was Carmen.
You know, I gotta say, whenever I think your name, in my head plays "Where in the world is Carmen Sandiego?" Do you not know the show I'm talking about? She wore like a red trench coat and like a big old hat. I am the most distractible teacher in the world. Are you serious? Pettigrew's more distractible?
Yes, she is.
Class, what's 3 times 6 across the top? 18. What's 10 times 10 across the bottom? Had a lot more people on the 18 than I did on the 100. And now to write 18 hundredths, I make sure my number stops in the second decimal place. Guys, remember my decimal poster moved over there. It's on the whiteboard. My decimal poster moved over here. Rachel, will you do my Vanna? Vanna White is from a TV show you guys probably don't know. Decimals, right? We're talking tens. Deci, it's tens. Fractions, you can do whatever you want though. And if you want to play with my fractions over there, you can try to make 1 in like the weirdest way possible. I love trying to make 1 in weird ways.
What's the best way you've seen? The last one gets little.
Man, somebody was playing with these yesterday, but they reset it when they were done. This one's the same as those magnets, but if you want to stack them and see like right where you get. So guys, if you want to play with fractions, play with them. Still random cards. Eli, how do you say this correctly? And guys, again, my advice is put the negative in the numerator. Put the negative in the numerator. So now straight across the top, 5 times -4, -20. Across the bottom, we get 100. Ooh, we could reduce it. -2/10.
Or -1/5.
Ooh, but if we want to go back to decimal, though, we should keep it over the 10.
Oh, my bad.
And the last one, and then I'll get you guys out of here. Class, how do I say this right? So anybody. -2/10. Ooh, not point. We don't say point. Times.
Multiplication? Oh, I didn't see that.
Yeah, that dot is there. Sorry. Times -7/10. Go across the top. Hey guys, now you might start to see why I said put it in the numerator. -2 times -7. +14. 10 times 10? 100. We get 14 hundredths, making sure we end in that second spot. Have a wonderful Tuesday.
Everybody's dead.
Oh, red jacket. I don't know whose. Red jacket. It's yours? Sweet. Get it on your way out. Black beanie? No, it's not. He said it's not. He said he knows where both of his are. Max. Max who? Hey. Are we good? I'm going to stop this real quick.